So today we will discuss about diffraction grating, right? So in the previous video of physics we discussed about diffraction, and today we will discussing about diffraction grating. So basically diffraction grating is a device, right? Let's give you an intro. It's a device which is used to calculate the wavelength of light with accuracy, with higher accuracy, right? With higher accuracy. And one other thing that it is used to separate the beam of light. It's to separate beam of light into its constituent colors. Beam of light into constituent colors, right? Basically it uses Fraunhofer diffraction, right? It uses Fraunhofer diffraction, in which there were parallel uh, parallel rays of light, like we have discussed in my previous video too. Let's discuss about this. Consider that we are having, okay, basically in this there is a glass transparent slit. There is a glass where are a lot of slits, right? Let's make the glass with slits. Basically there are a lot of slits. Basically the light we use has the wavelength of 400 to 700 nanometer, right? So that's why this, like, as we know that for the diffraction to occur, the wavelength of the light in a slit, the distance between two slits must be equal or approximately equal. So basically there will be, you can say, 4,000 to 6,000 slits per centimeter, right? And these all slits will be equidistant. These are slits in a are, like, my image is not properly correct, but if you see in Google or somewhere else in your book, so they are the distance between two slits, it's equal. It is known as equidistant, right? And here we are having, like, these are the rays of light. Okay, these are the rays. These are the rays, and they will fall. Then we are having a converging lens over here, which is known as a convex lens. Right here we have a, like this. Basically this is a ray diagram. This is a ray diagram, and here we have a screen over here. Basically we have used, because as you can see over here, these slits are parallel, right? These slits are parallel. So in order to converge, in order to focus them in a particular point, we have used a convex lens. We have used over here a convex lens, which is known as a converging lens, right? Converging lens. Basically it will focus all the light over here, and it will be like this, at this position, and a bright fringe will form over here. Bright fringe, right? Okay, now let's look the path difference over here. When we look at the path difference, okay, see over here, the path difference will be this. Right, and this is R1, this is R2. Let's find the path difference over here. As we know, the formula of path difference is basically S, and S here will be S1 minus R1 minus R2. Why? Because here we find the difference between a larger quantity and the smaller quantity. Here the R1 is more large than the R2. That's why we have done R1 minus R2, right? Then there is a path difference, and here we have a angle theta. We have an angle theta over here, and opposite to angle theta we have perpendicular, and here we have hypotenuse, and here we have base. Basically the distance between two slits is known as D, and this D is known as grating element. This is known as grating element. That is known as, let me write it over here, grating element. This D is known as grating element, right? Now if we find out that sine theta is equal to, basically sine theta, we know sine theta, like some people have perpendicular upon hypotenuse, so it will be sine theta is equal to, okay, we have P, which is known as over here, let's see what's that, it is basically here R, right? It will be R upon hypotenuse, which is distance, right? Here we have, now it is sine D sine theta is equal to, sorry, it will be S, which is the basically the path difference. This is equation number 1, this is equation number 2. Let's combine these both equations, and then it will be equal to D sine theta is equal to R1 minus R2, right? Basically the formula of the, we know that the formula of the constructive interference of is D sine theta is equals to n lambda. This is basically the equation number 1, right? This is basically the equation number 1. Here we will combine this both equation. Now it will D sine theta will be equal to n lambda. Here the condition satisfies that basically this whole derivation is to just prove the formula that D sine theta is equal to n lambda, and this condition is for constructive interference, right? Now basically one more thing which will help you guys is the order, like 0 order image, first order image, second order image. For this, consider that here we are having another slit. Here it is another slit, right? And here are the rays of light which are coming, right? And these are something like here, and I have placed the convex lens in this position, and now this is a screen basically, and now they are converting it into this. So now over here a bright fringe will form. Here is a bright fringe will be formed over here. Now one thing to remember over here, like if we create a normal over here, it will be like this. This is the path difference, and here it will become a theta. It is on the lambda, 2 lambda, 3 lambda, 4 lambda. Now you'll be wondering that where this lambda has come from. Basically like in maths there is you can say a concept, like if this is a triangle, and this is a point, this is m1 and this is m2. If the distance between m1 and m2 is, for example, x, then this will be 2x, like double over here. So we have applied the same over here again. So if the path difference of the, you can say, of between point A, like this is point A and this is point B, if the path difference between these both A and B is lambda, then we have first order image, right? But what if we have, like, if we have 0, like there isn't any kind of lambda over here, we have 0 lambda, then that is known as 0, that is known as basically 0 order image. If the lambda is like 2 lambda, if the path difference is 2 lambda, then that is known as second order image, right? So here the formula will be d sine theta is equal to 0 lambda, like, because we know that basically for the constructive interference, d sine theta is equal to integral multiple of the lambda, right? This m lambda, what does that mean? What does this mean? Basically we have the condition m lambda. So what does that mean actually? This means that the lambda is integral multiple of this, right? This is integral multiple, right? So that's fine. If we talk about this now, like, this is for this condition, right? If we talk about this condition, it will be d sine theta is equal to 2 lambda. It will be 2 lambda. This will be the condition over here. So I hope this is clear to you. If you have any kind of queries, you can ask me in the comment section and I'll be very glad to answer you guys.